Ordovician-Silurian extinction event, 439 million years ago. Over 439 million years ago, life on Earth was thriving, though it existed almost entirely in the oceans. Trilobites, brachiopods, and early corals dominated shallow seas. Unaware that the planet was about to face its first mass extinction, the Ordovician-Silurian extinction would become one of the most devastating biological crises in Earth's history. It came in two waves, both driven largely by drastic climate shifts. As the ancient supercontinent Gondwana drifted over the South Pole, global temperatures plummeted. Massive ice sheets formed, locking away ocean water and causing sea levels to fall sharply. Shallow marine habitats, the most biologically rich areas at the time, vanished. Countless species simply couldn't adapt to the sudden cold or the loss of their homes. But the second wave came just as the Earth began to warm again. As the glaciers melted, sea levels rose rapidly, disrupting ocean chemistry and possibly triggering low oxygen levels in deeper waters. In total, an estimated 85% of marine species disappeared. This included many types of coral, trilobites, and reef builders. Entire ecosystems collapsed in the span of just a few million years. Scientists continue to explore other possible causes, including volcanic activity and even gamma-ray bursts from space. But what's clear is that this extinction was a turning point. Late Devonian extinction event, 368 million years ago. But around 368 million years ago, Earth faced another crisis, the Late Devonian extinction. Unlike the sudden blow of the first extinction, this one was a slow, drawn-out collapse, unfolding over millions of years. This extinction primarily affected marine life, especially the vibrant reef ecosystems that had once dominated the Devonian seas. One key factor was the rise of land plants. As they spread across continents, their roots broke down rocks and increased the flow of nutrients into the oceans. This nutrient surge may have triggered widespread algal blooms, which consumed oxygen and led to anoxic, oxygen-depleted conditions in the seas. Other theories suggest volcanic activity, climate fluctuations, and even possible asteroid impacts may have contributed to the prolonged stress. Around 75% of marine species vanished. Reef systems collapsed, never fully recovering until millions of years later. Major groups of fish, including many armored species, went extinct. Only the most adaptable forms survived. In the aftermath, the species that endured were often those able to cope with low oxygen environments or adapt to changing food sources. Small, bony fishes with better gill structures and faster reproduction began to dominate. Some marine organisms shifted to deeper waters or adapted to more nutrient-rich, murky conditions. Permian-Triassic extinction event. About 251 million years ago, Earth experienced its most devastating biological disaster, the Permian-Triassic extinction, also known as the Great Dying. Over 90% of marine species and around 70% of land species vanished, making it the most devastating extinction in Earth's history. Life before the event was thriving. Vast forests covered the land, reptiles roamed, and the oceans teemed with shelled creatures, corals, and early fish. The leading theory points to massive volcanic eruptions in what is now Siberia, known as the Siberian Traps. These eruptions released enormous amounts of carbon dioxide and methane, triggering global warming, acid rain, and ocean acidification. The planet's temperature rose rapidly. Oceans lost oxygen, suffocating marine species. On land, extreme heat and toxic air devastated plant life, destroying food chains. Additional factors, like methane hydrates released from the seafloor and possible asteroid impacts, may have added to the chaos. The effects were total. Coral reefs vanished. Trilobites, which had survived previous extinctions, finally disappeared. Yet amid this near-total collapse, some species found ways to survive. Certain burrowing animals escaped the worst surface conditions underground. A few small reptiles and amphibians adapted to rising temperatures and low oxygen. In the oceans, early ancestors of modern fish and crustaceans clung to life in isolated, more stable environments. Triassic-Jurassic extinction event, 199 to 214 million years ago. After the devastation of the Permian-Triassic extinction, life began to rebuild. New species emerged, ecosystems stabilized, and reptiles diversified across land and sea. However, between 214 and 199 million years ago, the planet experienced another extinction event. Although the extinction was less severe than the one before it, it is still significant. Around 70–75% of all species vanished, including many amphibians, large land reptiles, and marine life, and cleared the way for one group in particular to rise: the dinosaurs. The causes of this extinction are still debated, but one of the strongest theories points to massive volcanic activity linked to the breakup of the supercontinent Pangaea. As the land split apart, enormous volcanic rifts erupted, forming the Central Atlantic Magmatic Province, CAMP. These eruptions released vast amounts of carbon dioxide and sulfur dioxide, leading to global warming, acid rain, and rapid shifts in climate and ocean chemistry. Other contributing factors may have included methane releases, sea level changes, and even potential asteroid impacts, though the evidence for a space collision is less clear than in other events. The extinction hit hard across the food chain. Cretaceous-Paleogene extinction event, 65 million years ago. For over 160 million years, dinosaurs ruled the land. Flying reptiles soared the skies, and giant marine reptiles dominated the seas. But around 65 million years ago, their reign came to a sudden, catastrophic end. A colossal asteroid impact. A 10-kilometer-wide asteroid slammed into what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater. The force of the impact was billions of times more powerful than a nuclear bomb. It instantly vaporized everything for miles and launched dust, debris, and sulfur high into the atmosphere. Thick clouds blocked sunlight, plunging the planet into darkness. At the same time, acid rain fell, and wildfires scorched forests around the globe. This impact may have occurred alongside intense volcanic activity in India known as the Deccan Traps. The result? Nearly 75% of all species on Earth were wiped out. This included all non-avian dinosaurs, flying reptiles like pterosaurs, and many marine creatures. Only small, adaptable, and often burrowing species had a chance of survival. Among the survivors were mammals, birds, and reptiles that could withstand harsh, unstable environments. Tiny mammals began to thrive in this new world. Over time, mammals diversified into the vast range of species we see today, including us. Holocene extinction, present day. Unlike the ancient mass extinctions that took millions of years to unfold, the sixth may be happening right before our eyes. Known as the Holocene extinction, this ongoing event began roughly 10 years ago, at the end of the last ice age. But in the last few centuries especially, since the Industrial Revolution, the pace of species loss has accelerated dramatically. Through habitat destruction, pollution, climate change, overhunting, and the spread of invasive species, human activity has pushed countless species to the brink. The International Union for Conservation of Nature, IUCN, reports that over 42 species are currently threatened with extinction, including a staggering number of amphibians, mammals, birds, and plants. The leading theories point to a combination of factors. 1. The unsustainable hunting and fishing that has wiped out populations like the dodo and passenger pigeon. Another is habitat loss, driven by deforestation, urbanization, and agriculture. Climate change, fueled by fossil fuel emissions, is altering ecosystems faster than many species can adapt. Coral reefs, for example, are bleaching and dying at unprecedented rates due to rising ocean temperatures and acidification. The latest evidence, including a 2019 UN Biodiversity Report, warns that 1 million species could face extinction in the coming decades. The current rate of extinction is estimated to be 100 to 1, 0 times faster than the natural background rate. Some scientists argue we're already deep into a sixth mass extinction,